All right, so we are going to be working through a few questions on this unit test, and then we're going to start another one. So we're going to be going over all exponential models, okay? Now, this right here is called an exponential model. And what I'd like you to do in your journal is simply write this down as it appears. And we're going to explain what each part means, all right? Right here, I'm going to rewrite it as L, whoa, wow, L of t equals a times b to the power of x. Now, in an exponential model, you have this thing called your a value, and you have this thing called your b value. Now, your a value is always your initial amount, and the b value is either what's called the growth, or it's sometimes referred to as a decay factor. Okay, so if you have a times b to the power of x, now this is L of t. Most of the times you'll see f of x, and instead of an x, there'd be a t here technically. So you know what? So people aren't confused, I'm just going to use f of x instead of L of t, if my board will let me. There we go. F of x just means your y value. So if the b value, okay, if the b value is greater than the number 1, that means you get to grow. So if b is greater than 1, we call that a growth factor. But if b is less than 1 but greater than 0, it's going to decay. All right? If you're wondering in exponential functions, what does growth look like? It usually looks like this, where it goes up. What does a decay graph look like? It goes down from left to right. That's not a very good graph because technically it doesn't go back up. It just goes down and gets close and close and close to 0. All right? So right here, what does it look like for us is happening? Is this bigger than a 1? Yes. Okay? So your b value right here is 5 over 3, but notice right here it has t over 5.9. So it is gaining 2/3. Like, how does it gain 2/3? Well, it starts off with 100%, and which is 3 over 3, and it's gaining 2/3. That's why this number right here is actually 5/3. So if it gains 2/3, that's why the b value is 5 over 3. Okay. Now it doesn't gain that until this number here actually reaches 5.9 days. If you can see this, because what's 5.9 divided by 5.9? 1. And so it gains 2/3 every 5.9 days. That's why this didn't require a lot of thought. Okay? But this right here lets you know it has to reach 5.9 days before it actually gains that 2/3, or multiplied by 5 over 3. Okay? Now, here's something I want you guys to understand. If you wanted to know the actual b value, you would take 5 over 3 and you would multiply it, okay? Multiply it by 1 over 5.9. So watch what happens. Take my calculator here. Parentheses, 5 divided by 3. Let's try that again. Raised to the power of 1 divided by 5.9. So every single day it reaches this. But look what happens when I do 5 divided by 3. And right here I put 5.9 divided by 5.9. that's when it gets you to 5/3. So it actually takes 5.9 days before it increases by a factor of 5/3. So what does it increase every day? It increases 1.09. So look at this. Look what happens if I take this right here and I raise that to 5.9. That gets us to what? Back to 5/3. Okay? So right here, it's going to increase every what? Every 5.9 days for this one. Okay? All right. So what I'd like you to do on this one is you don't have to read all the words. I'm going to write down what you need to know. Here's your function. Okay? We have P of t equals 6 times 1.43 raised to the power of t. Now, what does t represent in our problem? The only thing I want you to write down is what does t represent? T represents days. Okay? So Marcus sent a chain letter to his friends, asking him to forward the letter to more friends. So what did he start with? What was the initial amount of chain letters? 6. So that was the initial amount. Okay? That's your A value. What's the growth factor? How do I know it's growth? Because it's bigger than 1. So what's my B value? 1.43. So if it says what's the growth factor, you say 1.43. But it says what percentage, what's the daily percent added to. Now you're either only adding or subtracting from what percent? What do you think? What are you adding or subtracting from? 100. So I want you to understand is you actually, in this particular problem, are adding 43% to get to this concept called 143%, because 143% written as a decimal is 1.43. So when you have a growth factor of 1.43, I need you to understand that what is it increasing by? 43%. So part of this whole thing we're doing right here is I want you guys to have better understanding of what adding percentages to something over and over and over again. So every single day, 43% are being added to the number in the chain letter. So part of this is just helping you guys understand how the real world works with exponentials and percentages. Okay? So right now, I'm going to go over here. What am I going to type in? 43 and added to. Okay. Last problem for this particular period. P of t equals 12 times 5 to the power t over 3.6. This is another easy one, because what does t represent? T represents months. Arthur sent a chain letter. Wow, everybody's sending chain letters. All right, so what does this 12 represent? Our A value. What does the 5 represent? That's the B value. That's the A value. And so it's growing by a factor of 5, not every month. Every how many months? Every 3.6 months. It grows by a factor of 5, not every month. Every month it grows by a factor of 5 to the power of 1 over 3.6, which is some approximate value. But we're going to type in 3.6 months for that one. Okay? Oh, sorry. All right. I know this problem's kind of hard to see, so I'm going to write a little bit bigger. It has like an E, then it has the word year, like down there. Then it has a parentheses, a T equals 100 times 1.7 to the power of T. Now, whenever you guys are doing these problems, it's very important that you understand that T represents years. Okay, now this is called an exponential model. And once again, we have different numbers that mean different things. So if I have the normal f of x equals a times b to the power of x, once again, a represents your initial value. B represents what's called your growth or your decay factor. Just remember, if B is greater than 1, that's going to be what's called a growth factor. But if B is a fraction, which means it's less than 1, but greater than 0, that's called a decay factor. All right? So what is our A value in this particular problem? We're starting with what's called 100. All right? So right now, the number of exercises on Khan Academy has increased rapidly since it began in 2006. So what are they saying that it started with? How many exercises did they start with in 2006? They started with 100 of these little exercises, okay? Now, it's been growing by a factor of 1.7 every, what? Every year. No, exercises are the assignments. When I give you guys different assignments, those are called exercises. Like it's an assignment that you have to complete. All right. Here's the thing though. It says complete the following sentence not about the yearly rate of change, but the what? The monthly rate of change. Interesting. So we got it. If this is what's happening every single year, what's happening every single month? So here's what you can do. Check this out. Would you guys agree in 1 year time it increases by that factor to the power of 1? But how many months are there in a year? There are 12 months. So I want you to understand this is equal to the yearly rate. Let's see if this makes sense to y'all. Ready? What did I just write? 1.7 raised to the power of what? 1 over 12. Why did I put 1 over 12? Because a month is what? 1/12 of a year. So check this out. Get your calculator, see if I can prove it to you. Okay? If I have 1.7 and I raise that to the power of 1/12, you get this decimal. Okay? Now take that decimal right there. If that's your monthly rate, how many months are there in a year? 12, right? If I raise that to the power of 12, look what it gets me back to. 1.7. So what I'd like you to do in your journal is write this down next to this. 1.045. I'll go back and I'll write it down. 1.045. So what is our approximate value as a decimal? 1.045. That's what we call our monthly rate. And 1.7 was our yearly rate. Does everybody see right here it says round your answer to how many decimal places? 2. So if I want to round it to 2 decimal places, that would be 1.05. Why would I have to put a 1.05? Because if that's a 4 and then a 5, if that's a 5 or higher, it rounds up. So right here, I'm going to write 1.05. Okay? By the way, this is just one problem. I'm not expecting you guys to know everything from just one problem. Did I put 1.05 there? Does that look good? Okay. After a special medicine is introduced into a petri dish containing a bacterial culture, the number of bacteria remaining in the dish, what has happened to it? It decreases rapidly. So here's what I'd like you guys to do. In your journal, all you have to write is the one that this problem is dealing with is not increasing, it is decreasing. So this is going to be an example of a decreasing model. So just put in your journal, put this is a decreasing model. The population loses 1/4. So write down, it loses 1/4 every 44 seconds. Every 44 seconds. Okay? The number of remaining bacteria can be modeled by the function n, which depends on the amount of time in seconds. So can you guys put t equals seconds? Okay? Before the medicine was introduced, there were 11,880 bacteria in the petri dish. Can you guys write the A value? Our initial value is 11,880. What does the word initial mean to y'all? Very good. At the beginning, at the start. So that's what you start with. So the word initial means at the start or at the beginning. Okay. Write a function that models the number of remaining bacteria t seconds since the medicine was introduced. Okay. So guys, does everybody understand what losing 1/4 of something means? If you lose 1/4, what percentage would that be? You're taking away what? You're taking away 25%. What are you keeping? 75%. So I want you to understand, if you lose a quarter, you're losing 25% of whatever you started with, which means you are what? Keeping 75%. Does anybody know what fraction 75% is? 3/4. And what decimal is equivalent to that fraction? There we go. I want you to understand, you can use this or you can use this as your B value. So your A value was 11,880. Your B value, I'm going to use 0.75 because it's pretty easy to type in. Like, I thought it was 25%. No, you're losing 25%, but what are we keeping? That's why we got to use the B value as 0.75. So be careful. Students will miss this problem because they will use the 25% instead of using the 75% that you're keeping. So here's your final answer, guys. I think I'll do it in orange since you can actually see it. Here we go. N of t equals our A value times our B value raised to the power of t over 44. 44. You're like, whoa, where'd you get the t over 44? Because it didn't say every second, it says every 44 seconds. So we got to be mindful. It's not happening every single second. It's happening every 44 seconds. So what is our A value? Very good. So we write that. In parentheses, what am I going to put as my B value? It's 0.75. And then I'm going to raise that to the power of t, but I have to put divided by 44. This is your answer for this problem. Now I'm going to carefully type that in so you can see that that's going to work. Because if you lose 25%, what does that mean you keep? You still keep 75%. If you lose 10%, what do you keep? 90%. If you lose 20%, what do you keep? 80%. If you lose 5%, what do you keep? 95%. Okay, so we're going to type this in. 11, is it 880? Okay, parentheses, 0.75, close parentheses. I got to raise that to the power of another fraction. Got to put t over, hold on, got to go down. I think I got everything typed in there. There we go. All right, so we're going to take a look at this problem. All I want you guys to write down is this right here, because we're going to interpret what this means. So if you would, please, in your journals, just write down C of t equals 95, parentheses, 0.87 to the power of t. It looks like t is in minutes. After a certain medicine is ingested, its concentration in the bloodstream changes over time. Here's the relationship between t in minutes and C of t, whatever is left as this function. Now, every single minute, the concentration, 0.87. Is that bigger than or less than 1? So that means it's not growing, it is shrinking, it's decreasing. And every single minute, what's it decreasing by? A factor of 0.87. Now listen, they could also ask you this question, and it's actually losing a certain percentage. Does anybody know what percentage it's losing? It's keeping 87%. So what percentage is it losing? It's losing what? 13%. So I want you guys to understand, we could get another question, and instead of it being a factor, it's saying what percentage is it losing? And you'd have to say it's 13% is being removed from that specimen every single time. So if you're multiplying by something by 0.87, what's happening each time? You're losing, each minute, it's losing what? 13% of whatever it had. Okay? So right now, all I'm going to do is put shrinks and put a factor of 0.87. So we say shrinks. What's our factor? 0.87. Okay. Oh, tricky, tricky, tricky. Okay, guys, T equals decades. What is a decade? 10 years equals 1 decade. What are we starting with? 4,900. What's our growth factor? 1.5. But that's per decade. That's not per year. So we're going from a decade, which is big, to a year, which is small. So if we're going from big to small, and we want to know what that factor is, it's not going to be 1.5, because what does 1.5 represent? A whole decade. So per year, we have to raise that to the power of 1 over 10. Why are we doing it to the power of 1 over 10? Because there's 10 years in a decade. Does that make sense? So what do we have to do in the calculator? We have to do 1.5 to the power of 1 over 10. So let's do that. 1.5 raised to the power of 1 over 10. So every year, it grows by a factor of 1.04. Okay? Now this may not make a whole lot of sense, but we'll see if this makes sense. Ready? We're starting with what? 4,900, right? In one decade, if I say to the power of 1, it gets to that. Correct? Now look what happens if I take 4,900 and I multiply it by that. How many times do I have to multiply that by if it happened every single year to the power of what? 10. Well, here's the problem. It's not the same, but unfortunately, hold on. What if I did this? You know why? Because it's taking the decimal, it's not taking the whole thing. Hold on. What I'm saying is, hold on. Oh, it's supposed to be 1.5. Okay. Yeah, that's where I messed up. That was the last problem. Okay, that's better. Okay? So it should, yeah, that now they match. Okay? So what does this represent? This represents the yearly growth. What does this represent? The decade growth. So I'm going to type in 1.04, because what do I have to round it to? 2 decimal places, not 3 decimal places. So does everybody see why I'm rounding it right here to the 2 decimal places? Okay? So if you're going from a decade to a year, you're going from something that's bigger to something that's smaller. So that's why we raise it to the fraction of 1/10 to get your answer. We'll probably get another one like this. Okay. There's a lot to interpret in this, so all I want you guys is to write this down and we'll interpret it. We're going to do 2 more problems, then I'll let you guys go ahead and see how you guys do without my assistance. 2 more, and I'll let you guys go ahead and see if you can figure it out. Okay. So right now, does anybody, if I said, what's our A value? Not even looking at the words. What's my A value? What am I starting with? 320. What's my B value? 0.125. Okay. What percentage is that? What percent? So that means it keeps what? 12.5%. How much is it losing? 87.5%. If it keeps 12.5%, it means it's losing 87.5%, but it's not happening every single day because T represents days. How many days does it take in order for it to lose 87.5%? It actually would take, what, 61.4 days before it would lose 87.5%. Why? Because 61.4 divided by 61.4 is equal to what number? 1. And so it raises us to the power of 1 every 61.4 days. Okay? So what do I need you guys to understand? That in percentages, when you guys go to a store and it says 30% off, what do you still have to pay? 70%. If it says 20% off, what do you still have to pay? 80%. Okay? If it's 50% off, you only have to pay 50. That's the easiest one, right? 50% means it's what? Half off, but you still have to pay half. So right here, look what it says. It says it's losing. This is where students get confused. They're like, how did it get loses 87.5%? Because it's keeping 12.5%. But it's not every day. How many days does it take? 61.4. That's why the answer is going to be 61.4. Yeah. You just have to know what you're looking for. If you don't know what you're looking for, you'll never find it. So I'm trying to teach you guys how to interpret exponential models. And if you miss one, just look at the step-by-step solution. All right, here's our last one. This is one of the most commonly missed ones right here. So write this last one down. I'm not telling you what it is. Sorry, there's a student's like, is it 2? No, actually the answer is not 2. Don't worry, I'm not going to call you out. All right? I won't call you out. Okay, so listen. Let's think about this. I'm going to write this down. Ready? Every 2 days, it loses 51%. Because what is it actually keeping? No, it doesn't keep 51%. It keeps 49% every 2 days. Okay? But it says what? Every day. What's it multiplied by a factor of? Every 2 days, it's multiplied by a factor of 0.49. Every 2 days, that's the factor. Every 2 days. But every day, it's not multiplied by that factor. So to find that piece of information, you take 0.49 and you don't raise it to the power of 1, you raise it to the power of 1 over 2. Why 1 over 2? Because it's happening every 2 days, not every day. So you put 0.49, raise it to the power of 1 half, and that will give you your answer for every day. And you should get 0.7. If you do 0.49 and you raise it to the power of 1 half, it's 0.7. So my answer for this is 0.7. Now, if it said every 2 days, my answer would be 0.49. But if it's every day, it's multiplied by 0.7. And what's my clue of finding that? This fraction right there. So I put 1 over 2. Because what does t represent? Time, and time was in what? Days. So that's why I put a 1. In 1 day, 1 over 2, it's 0.7. Now you guys can go ahead and start on this. I'm going to keep going on the video, and you guys can go ahead and start. It's right there assigned on your Khan Academy. But I'm just going to keep going. You don't have to pay attention to me unless you just want to learn more. All right. So I'm going to go a little bit faster because now I'm not going to be teaching people. I'm just going to be doing problems. After a special medicine is introduced into a petri dish containing a bacteria culture, the number of bacteria remaining decreases rapidly. The number of bacteria decays by a factor of 1/15th. Wow. Every 6.7 minutes. All right. So we get to write this. So we got 1/15th is our decay factor. That's our B value. Our A value, it looks like we're starting with 90,000 bacteria, okay? And it decays by this factor every 6.7 minutes, and it looks like T's in minutes. This makes this very easy. Here's my final answer. Our initial amount is 90,000, so I'm just going to put 90,000. Our decay factor is 1 over 15, so put 1 over 15, and it's happening every 6.7 minutes, so I'm just going to put T over 6.7, and that's it. That's my answer. All right, I'll just type that in. Parentheses, 1 divided by 15. And I got to raise that to the power of T over, oh, that's too much. Got to raise that to the power of T over 6.7 minutes. Okay. Nailed it. That was easy. Okay. Complete the following sentence about daily percentage of locust population. All right. On the first day of spring, an entire field of flowering trees blossom. The population of locusts consuming rapidly increases. So it looks like T is days. Sweet. There's T is days. And it says complete the following sentence about daily percentage. Oh, sweet. This is easy. We got 1.65. Now, if you guys don't know, I'm going to break this down into 100% plus 65%. And just so you guys know, the decimal for 100% is the number 1. And the decimal for 65% is 0.65. When you add them together, you get 1.65. So I know that every day is a 65% increase that's added to the total locust population. So that's all you got to do. Just take that number right there, break it down into its percentages, so you know that 65% is being added to it over and over and over again. So I'm just going to type in 65 added to, and we'll see if I am right. 65% is being added to. Hey, it worked. All right, Nicholas sent a chain letter to his friends, asking them to forward the letter to more friends every 12 weeks. The number who received increases by an additional 99% every 12 weeks. Okay, so if we have 100% and it's increasing by an additional 99%, that means we're at 199% every 12 weeks. Now, as a decimal, that's 1.99. That's my B value, but it's not every week, it's every 12 weeks. Initially, he sent it to 50 friends. So my A value is 50. My growth factor is 1.99, but it's not happening every week, it's happening every 12 weeks. So I'm going to put T over 12, and that's my answer. Wow, additional 99%. If you're wondering how I learned this stuff, I just learned by watching other teachers who knew how to do stuff and watch the patterns and realize that's how it works. Once you learn the pattern, you can do that pattern over and over again. And eventually, if you get good enough, it just pays the bills. The great thing about being a math teacher, though, is that there's so many people who don't understand math. Your job is never in jeopardy. All right, raise it to the power T over 12. So not every single week, but every 12 week, it gains an additional 99%. Oh my gosh, I got another one right. It's like I'm talking smack to Khan Academy. But I'm not, because I love the Khan Academy. They make my job a lot easier. Oh, I got two more to do, then I'll help you. Right now, you guys should know what to do now. All right, so it looks like we got n of t equals 300. That's my a value. And then we have 49 over 16 to the power of t. That's our b value. And it looks like t represents weeks. Interesting. So it gains 3/4. Let's think about this. If I have 100% and I'm gaining 3/4, that means I'm gaining 75%. Now 100% in fourths is 4 over 4. And if I'm gaining 3/4, if I remember how to add fractions correctly, if the denominators match, I can add the numerators together and get 7 over 4. So if I gain 3/4, now I'm at 7/4. Well, that's not 7/4, but watch this. This is amazing. Would you guys agree that 49 can also be rewritten as 7 squared? And would you agree that 16 could be rewritten as 4 squared? Which means if 7 is being squared and 4 is being squared, then I could actually rewrite this as 7 over 4 raised to the power of 2. Now, what's already sitting out there? A t. Here we go. I just rewrote my function. I went from 49 over 16 to 7 over 4 raised to the power of 2, which is the exact same thing. Now, I just want to gain 7/4. I don't want to gain 49 over 16. So what could I do? Like, what would I have to plug in here for that to equal a 7/4? I would have to plug in a half, because 2 times a half is to the power of 1. So I think it's only going to take me a half of a week for it to gain 3/4 of its original size. So what am I going to type in? A half. All right. Find out. Find out if I'm right or if I'm not. Oh, that was careful. That was a close one. Typed in 1/3. Oh my gosh, nailed that one. All right. Gottfried. I'm so glad my name's not Gottfried. Wanted to see how contagious yawning could be. Oh, so tired, so sleepy. Okay, you feel like you want to yawn right now, don't you? Oh, got one. Got one. To better understand this, he conducted a social experiment by yawning in front of randomly large crowds and observing, oh, sleepy pillow time. How many people yawned as a result? Okay. The relationship between the elapsed time t in minutes, t equals minutes, is modeled by this function. Oh, we got to be careful here. It says p minute, not p diddy, but p minute, t equals 5 times 1.03 raised to the power of t. Now, our b value right now, our b value is 1.03, but that's dealing with what? Minutes. Would you guys agree a minute is smaller than an hour? How many minutes in an hour? So that's right, 60 minutes in an hour. That's why I was like, yeah. So 60 minutes, right, equals 1 hour. Maybe this makes sense to y'all. If this is the minute rate, if I wanted to see the hourly rate, you take 1.03 and you raise it to the power 60. And that gives you your hourly rate. Does that make sense? If you go from a minute to an hour, because a minute's smaller and you're going to something bigger, you raise it to the power of 60. So that's what I'm going to do. I cannot do that in my head. I'm sorry. I'm just not that smart. Holy moly. That's a lot in an hour. Does everybody see that right there? 5.89. So that equals 5.89. There we go. And that's what I'm going to type in. So how do we go from minutes to hours? Raise it to the power of 60. If I wanted to go from hours to minutes, what would I have to do with this guy? I'd have to raise it to the power of what? 1 divided by 60 to get me back to the 1.03. Okay? And that's how math works. So what am I going to type in right there? 5.89. Hopefully I rounded it correctly. I'll check back real quick at the old calculator. 5.89. 5.89. 5.89. Holy moly, that's 200s in a row. That's all I'm doing for today. Have a good day.